Today we're looking at Glencoe Accelerated Math Lesson 5.5, which is on determining if relationships are proportional or non-proportional. Now, if something is proportional, that means that it has the same unit rate no matter what data point we choose. Okay? When we were solving for unit rate, everything was proportional. It didn't matter which data point we used, and sometimes we were only given one, but that would give us a unit rate, and it would be consistent across all numbers. Okay? Sometimes, though, things happen that aren't proportional. For example, if something is on sale, like when you sign up for a 2-year contract with T-Mobile or Sprint or whoever's offering it at the moment, and you get 2 free phones. Woohoo! Okay? Well, the price of the phone is not proportional compared to those that don't sign up for the 2-year contract. Right, because in one instance it's free and in the other instance you pay. So it's not proportional. In both instances you still have to pay for service. But yes, I know what you're saying.
So they jack up the price of the service.
Regardless. Okay? Either way, if we're looking at a line item in a budget and it says phone, one line item would say $0, the other one would say a value. Okay? Or if you buy concert tickets and you go to Ticketmaster or StubHub or something like that, they charge you based on the number of checkouts, not based on the number of tickets. So it is more cost effective, or it can be more cost effective to buy 4 tickets compared to 2 tickets. Okay? Because you're paying less than those fees. But something like a movie ticket, if everybody goes to the movie theater together, is it cheaper if you buy 4 at once, or whether you each pay for your own ticket? No, it doesn't matter. That would be proportional because the cost of the ticket doesn't change. The cost of the ticket with taxes doesn't change whether you buy 1 or 2 or 12. That's proportional. Okay? Does everybody get that?
Yes, ma'am.
Okay, so then let's look at how we do the math to check it. All right? We are looking at page 206. 206. And there's 2 different ways that we can do this. Okay? There's 2 different ways we can check. The first way, and I'm looking at example 1. The first way says to determine whether the cost of coffee is proportional to the number of pounds. So if you go to the store, you can buy coffee or whatever in multiple sizes of containers. Coffee is generally sold by the pound. Okay? They want to know if the relationship is proportional. Identify the constant of proportionality. Well, guys, here's the fun part. You know what constant of proportionality is. Because the constant of proportionality is the same thing as a unit rate. We're just calling it something different. So if we can find a unit rate, we can find the constant of proportionality. Because the constant of proportionality is a unit rate. This chapter has a lot of different ways of saying the same thing. Okay? I know, insert sigh here. But that also means that if we can figure it out in one way, we can figure it out in any of the other ways. Okay? We're going to be looking at the same thing in multiple formats. Yay! Okay.
Wait, does that mean we have to remember all 4 different words?
Rate of change, unit rate, constant of proportionality, slope.
Wait, say those again. Slope.
Unit rate, rate of change,
Rate of change.
constant of proportionality,
Constant of proportionality.
slope.
Slope. We have to learn 9 words. Slope is like a circle.
But only 4 of them are actually vocabulary words.
But still.
It's because the vocabulary word is a phrase. Yes.
So have we already learned
Do we know how to find unit rate?
Yes.
You mean like
Unit rate?
yes? Isn't it a simple
No.
one?
Kind of, yeah.
I don't think rate like of central tendency. What is that?
Kind of, sort of.
Like, wait, are we gonna do units of central tendency?
Yes.
Yes, that is my favorite.
All right. Before we get off track thinking about other things that also have multiple words to mean the same thing, let's go ahead and let's look at our coffee. We have 1 pound and $3, or we can buy 2 pounds for $6.
Really?
Or we could buy
Oh, the unit rate. Oh, I'm slow.
3 pounds.
I remember
For $9.
$9.
Oh my gosh!
Or, guys, we don't want to disrupt the other class. Or, believe it or not, we could buy 4 pounds
For $12.
For $12.
For pounds?
for $12.
Oh my god!
Alright, shh. Now, guys, you sound like you guys drank coffee this morning and you guys don't need any.
I did! I drink coffee every morning. Coffee doesn't like you.
Guys, take a deep breath for me.
I have asthma.
Yes, sir.
Am I choking?
What about 30 pounds?
Okay, we could find out how much 30 pounds would be, but first we're going to verify that this is proportional. Okay? If this is proportional, then the relationship between pounds and dollars will be the same in every one of these situations. So this says we get 1 pound for $3. What's 2 over 6 simplified?
1/3.
1/3. Is that the same as this?
Yes.
Yes.
Yes. Okay. So that is, we have one that's the same. Guys, we don't need just one to be the same. Because if any one of these was different, then it's not proportional. Okay? We need them all to be the same. So, does 3/9 simplify to be 1/3?
Yes.
Yes. So, this one checks. That one checks. Does 4 over 12 simplify to be 1/3?
Yes. They're all times 3.
Okay? Right. So, yes, it is proportional. It is proportional because regardless of how many pounds we purchase, it is going to be $3 a pound.
Yeah.
Okay? So, if we were asked how much it's going to cost for us to have 30 pounds, how much would that cost us?
A lot of money.
30 times 120.
90.
$90. 30 times 3. Okay.
I'm smart. They're not.
Stop.
I did 30 times.
Yeah. All right. So, if we have a proportional relationship, we can go ahead and say, based on this constant of proportionality, based on this unit rate, we can figure out any other multiple of that. We can. If it is non-proportional, can we do that?
No.
Not really. We can't do it by multiplying. We might still be able to, but we can't by multiplying. Okay? All right. I want us to look at example 2. In example 2, we are told that we're trying to determine if distance is proportional to the time traveled. Okay? Is the distance proportional to the time traveled?
Yes. I don't know. Maybe.
What? Hold on.
No.
Hold on.
No.
Guys, stop guessing. Hold on. In real life, is it going to be proportional?
No, time travel's not a thing.
we're talking about the time that's traveled. So we're talking about a distance that is traveled compared to the amount of time that it takes us to get there. Alright? But if you've taken a long trip before, you know that sometimes there's nobody on the road. You guys, you can just drive for an hour or so, no issues. You also know that sometimes you can be in the car and there's construction or an accident or construction and an accident, and in an hour you travel nowhere.
And you run out of gas. And you're stranded.
Okay, hopefully you don't run out of gas and you're not stranded, but so we know that in real life it's not always proportional. Really. Because the distance that's traveled in the same amount of time can change. Even if it's the same person driving, you're on the same road, you leave at the same time, even if everything is the same except the road conditions, like an accident or construction, okay? So, we know that's real life. Let's check and see what we have in the book as our example to see what's going on. Because in a book and an example, can we make it proportional?
Totally.
Totally.
Jesus, totally.
So, we traveled 50 miles in 1 hour, and in 2 hours they traveled 70 miles in 2 hours, and in 3 hours they made it 90 miles.
That's 30 hours. 30 miles an hour.
Okay, I've got some people that are guessing.
20 miles an hour.
Hold on. Ladies and gentlemen, 50 miles per 1 hour. Okay? So we have a unit right here, correct?
Yeah.
We have some quantity per one of something else.
Yeah.
Okay. You guys with me? 70 divided by 2 is what?
35.
35. This is 35 miles per 1 hour.
Oh. That makes sense. No, it's 50 miles an hour.
Okay. 90 miles divided by 3 hours is
30.
30
Uh-oh.
per 1 hour.
That don't make sense.
Guess what, guys? I think they ran into traffic.
I don't think it's
Ha
right.
ha ha.
You don't think this is right?
No.
Why not?
No, I don't think it's right. It's not right.
It don't make no sense.
Oh, it's not proportional. Okay.
Oh,
It don't make no sense.
you don't make no sense.
You're saying I don't make no sense.
Let's not go there.
What about me?
Let's not go there. Considering we're on video today, let's not go there.
I'm Mexican. Shut. Oh my god.
You guys remember I can't edit stuff out, right?
Okay.
Oh, that's
Nope.
gotta be funny. That was.
Alright. Do you have a question about this? Then can it wait till the end? Okay. Alright. Ladies and gentlemen. Ladies and gentlemen. So we have this way to solve by simplifying and finding the unit rate. Could we have also multiplied by our unit rate to find another quantity to check it that way?
Yep.
So in 2 hours, if this was proportional, in 2 hours, how far should we have traveled? 100 miles. 100 does not equal 70.
No, it does not.
In 3 hours, how far should we have traveled?
150.
150 does not equal 90. So could we have solved this either way?
No.
Do both show that it's non-proportional?
It's not proportional at all.
Right. Both methods show that this is not proportional. Let me say that again. Both methods show that this is not proportional. You can pick the method you wish. Okay? Because here where it was proportional, could I multiply 2 times 1 and get 6?
Yes.
Going from 2 pounds, 2 times 3 gave us 6.
Yes.
And 3 times 3 gave me 9.
Yes.
And 4 times 3 gave me 12.
Yes.
So they would still check.
Yes.
Are we focused?
Yes.
Yes, okay. One more thing that we need to look at. Yes, ma'am.
It's basically example 1 mentioned that. Example 2 is like written that.
So, we could have written out 2 pounds over 6 equals 1 pound over 3. And 3 pound over 9 equals 1 pound over 3. And 4 pound over 12 equals 1 pound over 3. We could have written that out, showing that we found the unit rate for each. We could have done that. But what we did, so we discussed it instead of putting it on paper. What your problems will ask you to do is to tell whether it's proportional or not. They'll say, if it is proportional, what is the constant of proportionality? That means you will need to tell us what that unit rate is, and then it will say, explain your reasoning. So you'll have to tell me why. Okay? Right, so you'll have to tell me in some way. So you could say that because, 3 pounds over $9 simplifies to be 1/3, which is our constant of proportionality. Or you could say that multiplying, from 1 pound to 3 pounds says we multiply 3 times 3 and that gives us 9, which is still true. So in some way you're going to have to be able to tell me why. And you were able to do that in our discussion. Here we wrote it out. And we wrote it out in 2 different ways. It doesn't matter which way you use. Because both ways justify your answer. Yes, ma'am. Wait just a second. Alright. Do we have questions? Yes.
Can you do another example?
Yes. Okay. Let's look at example 3. When we're done. Okay. Example 3 tells us that there is a ratio Example 3 tells us that there is a ratio and a relationship between the circumference and the diameter of the circle. Alright, so we're going to use variable C over variable D. The circumference of the circle we're given is 12.56. And the diameter is 4. Okay? What we need to do here is find the unit rate. We need to find that constant of proportionality, which says that we're going to divide. And when we divide those, we get 3.14. Does anybody know what we call that special number? Yes. Pi!
I love pi.
Now,
3.14.
Now, we could go on and on and on with the decimal places. But for our purposes, we only need to know this part. Okay, we're not going to have to go out further than that. So we found that constant of proportionality, assuming that this is proportional. What we're going to do is apply that. So what the problem asks us to do it asked us to find a constant of proportionality, assuming that it was proportional. Did that happen? Yes. Okay. Then it asked us to find the circumference if we know the diameter of a circle. So we're looking for the circumference. We need to multiply my constant of proportionality, which is pi, times my diameter. What tells me that the diameter is 6. So we're going to multiply that 3.14 times 6, and that gives us 18.84. So, because this is proportional, my circumference in this problem is going to be 18.84. If we were given the 18.84 and 6, could we divide again to get pi?
Yes.
Yeah, because it is proportional.
Is that why you divide to check your work when you go right? Yes.
All right.